Okay, hi. This presentation is for the final project of the course Introduction to Deep Learning, CS 89. Uh, so in this presentation, I'm going to examine the performance of the LSTM neural network in predicting the stock price. So I'm going to firstly talk about the motivation objective, moving forward to the data pre-processing, and then I'm going to touch a little bit on the modeling and the performance evaluation. And finally, I'm gonna talk a little bit about like how to what kind of research I can do further to lifting the performance. When it comes to motivation, as we all know, the stock price is highly volatile, and people say it is impossible to predict, and it's just like a random walks. But as we can see, we can still extract a lot of patterns from those randomnesses trend. For example, this like a double bottom trend, right? Once the price break the restriction, it seems the trend forward is pretty promising. And we also know the recurrent neural network works very well in predicting the sequential data. So I just want to examine how well, right, the recurrent neural network is work in this case in predicting the stock price. So regarding the data, I downloaded the SPY index starting from 2000 to 2021 August from Yahoo Finance. And first, the problem I'm facing is how to uh, uh, normalize the data. As we can see, traditionally we usually calculating the scale from the training data set and transform the validation and testing using the scale from the training data set. But in this case, as we can see, the scale just changes dramatically along with the timeline. So if we transform the validation and testing using the all the data, which is the training data, it seems the scale is still going to be very consistent with each other, right? So in this case, I try to normalize like the data in within the windows, and I'm going to work on different windows independently. So by windows, I mean anyway we are going to extract the pre-processed data by extracting several lengths of the windows, right? So in this case, I'm going to look back for 50 time point and trying to use the last 50 time point to predict the future price, one step further price. So the original scale is like a price in these windows. And for the normalization, I'm just going to divide every price from the original windows by the previous price, and then minus 1. So basically, I'm transforming the price windows to like a relatively return rate windows. And I'm going to do the same to the targeted price. So in this way, I'm just normalize the data, and so it does not get impacted by the scale difference issue, right? Demonstrating on this plot. When it comes to the which RNN model to select, we have two options: LSTM and the GRU. GRU may be very faster to train, but LSTM may be more accurate, right, in terms of the performance. And also, we have different choice to prepare the data before feeding into the model. For example, we can feed the model one-dimensional sequence, just feed the model price. Also, we can adding other attributes, for example, the price volume, the calculated RSI, MACD, right, to make the data more enriched. So to make the decision, I actually examined all the four combinations and calculated their validation MAE, and it turns out the LSTM with one-dimensional data, just which means just using the price index alone, turns out to be have the lowest MAE, which is very favorable. And in the time in the how much time spent on each epoch, it also performs decent. And the model looks this way. It's like a three-layer stacked LSTM model, and each layer has 128 neurons. So before doing the model tuning, we need to calculate the benchmark performance so that we can compare with the final model. So for the benchmark, I just use the last 50 days average return rate to predict the one step forward futures prediction. In this case, we can see the predicted value is pretty closely aligned with the actual value, which is the blue line. And the prediction, the benchmark methods testing data sets MAE is around 4.7%. So I tried different optimizers with different hyperparameters. Turns out to be the Adam with the default parameters, end up being with the best model, with a very low validation MAE, and it's reached to this lowest MAE at the 23rd epoch. Using this like a configuration, this optimizer and this epoch, I predicted test data set and calculated the MAE. So this is around 95 basis point, which is much lower than the benchmark methods, right? And this is a plotted yellow line predicted one step forward prediction versus the blue line actual value using the best model we just selected. And this is actually an extension, right? Instead of doing the one step forward prediction, so this chart demonstrates how it performs this model for this model if we do like a 15 step forward prediction. But as we can see, this method does not doing very well in predicting into the future. As we can see, it does not capture the actual value very well. So the conclusion for this presentation can be, right, this LSTM model just 3-layer stack perform very well in the one step forward prediction, but not very good in the multiple step forward prediction. To better lifting the performance, especially in the multiple step forward prediction, maybe we can consider the following examinations. Firstly, maybe we can adding more indexes. For example, the gold index and interest rate, which has been proven to be very correlated with the stock price, right? And which can be also indicative of like the where the money is flowing. And secondly, we can even try a deeper model or even try different neural network models. For example, the one-dimensional CNN, or leveraging like a pre-trained model to see if there's any performance lifting. And then lastly, maybe we can even try a thorough hyperparameter tuning using a grid search methodology to see if different parameters and different optimizers can further reach a performance lifting. All right, I think that's all from me, and hope you enjoyed. Thank you.